everyone, and welcome to my talk, 8 Healthy Recipes Using Angular and RxJS. I hope that you're enjoying the conference so far. And before we start, just a little bit about myself. My name is Lamis. I'm from Tunisia. If you don't know Tunisia, it's a small country in North Africa bordering the Mediterranean Sea. And I'm already the founder of Angular Tunisia. I'm a GDE for Angular and recently a Not-Zero ambassador. I've been into Angular for the past few years, and aside, I'm a speaker, mentor, and a content creator. So without further ado, let's jump into our recipes. And a disclaimer again before we start. All food pictures in this presentation are purely made for aesthetic purposes, okay? So don't try to make a link between the RxJS I am trying to point out and the picture in the slide, because there is no relation between them and it does not reflect any of the concepts. And those recipes are nothing but like solutions, or to be more accurate, reactive patterns in order to implement a recurrent use case we face like every day as a developers when developing web applications. So every time I'll be presenting to you the use case and then the solution in order to achieve it in a reactive way. And of course, every recipe requires some ingredients, and the ingredients will be like most of the time are some RxJS operators. So let's start with the first recipe for bulk operations. And when we say bulk operations, it's the fact of running parallel network requests in one shot. Okay, you're kind of running more than one request in one shot. And again, here I have to emphasize something. The backend I'm using in all the examples I'll be introducing to you is a RESTful backend. Okay, so I have a RESTful backend, and in my web application, I am using Angular and RxJS. So we said, so bulk operations is the first recipe, running parallel network requests, and here I have my UI, okay, which is built in Angular, and I have the server, in my server, the API, the REST API, and when triggering some kind of event, I am going to send more than one request to the server. Okay, so this is what bulk operation is about. And an example of bulk operations is upload files, or let's say massive uploads. Okay, so in today's applications, when we are dealing with some upload scenarios, it's whether you have in your user interface or in your form, in your, let's say, screen in general, form, or any other equivalent, you have a file that you will upload some files to your server. So you can upload one or many, okay? The problem is when you decide to upload or to perform this request, okay? So in order to enhance the user experience, you have to you don't have to block the interface every time you will upload a new file. Okay, so you better upload it in one shot, upload all those files in one shot after an event, for example, submit button or any other like equivalent. Yeah, so this is the use case, massive upload. This is the example for bulk operations, whether you have many files to upload in one component, or you have like many uploaded files in different components. It's the same thing. The result is the same. You have to perform a bulk operation for whatever reason in order to upload those files. So this is the requirement, this is the use case, and what we need in order to achieve this is the fork join finalized CatchError operators, and a custom function. Let's start with the fork join operator and let's explain it. The fork join operator falls under the category of combination operators. Okay, so you want to combine the results of your streams. And I really consider fork join as a severe operator because it emits only one time at the end or at the completion of the observables. Okay, so only one emitted value. So here, for example, we have three observables, and the last value of the first one is E, the last value of the first one is G, the last value of the third one is 4, and I am passing the list of those three observables to my fork join operator. So what am I going to get is the last value emitted before the completion of each observable, which is E, G, and 4 respectively. Okay, and why this operator is like useful in the case of bulk operation, because in the bulk operations I only need the final result. I don't need what's happening. I don't need to know what's happening or going on all along like the streams and the observables. I don't care. I care only about the final result. For the upload, for example, I don't care what's happening along the way. I only care about like the status. Is the file uploaded successfully or is it uploaded with errors and stuff? I don't need something else. So yeah, so this is like useful, okay, in those cases. And so it emits only one value, which is the last value for each stream, last emitted value for each stream. This is what you need to know. The second thing that you need to know about fork join is that fork join respects the order. Okay, so I have here like this is the first observable passed, the second one, the third one, even though the third observable completed first. Okay, the last one completed before the others, but still the value is emitted the last one because I passed it the last one to the queue. And this is something important that you have to keep in mind also in order to like notice what's happening for your streams. Well, so now let's see what we can do like into code. So here I have my upload file method, which is available in my upload service, my Angular service dedicated for uploading files. And here the upload file takes as a parameter the file to be uploaded and returns an observable of file status. Okay, the file status will contain the like result, if it's uploaded successfully or not, and if an error happens, then a short description of this error. Why? Well, this is a basic example. And I have here two calls to the upload file. I have the first request and the second request because I have two files to upload. Okay, again, this is an example. In real world scenario, you're not going to like call it one by one and assign it as it is the case now. Okay, this is just an example to make you able to like follow and understand how the fork join works. Okay, but in the real world scenario, it will be dynamic. Okay, maybe you will like stock this in array and then map and return an observable at the same time. There are like plenty of solutions, but yeah, so keep in mind that this is like an academic example in order to like explain the concept. Yeah, and now those are the two first lines. The third line of code is calling the fork join operator that you can import from the RxJS operators, and I am passing to it an array of observables. Okay, this is the first one, and this is the second one, and the result here, okay, of this fork join is an array of the emitted value of the last emitted value by each observable. Okay, so it's like respectively the last status of the first file and the last status of the second file, as I am returning a file status in my observable every time. Okay, so this is how it works, and this is what it returns. And again, so this is this access callback. In my case, as I said, it's an example, so I am just logging files uploaded successfully, and that's it. If you have like a special treatment to do, you can do it in the success callback. Well, this is fine. So far, so good. We use the fork join, but in this case, we dealt only with the happy case. Okay, there's no errors, there's nothing wrong, no exceptions at all. Okay, everything works fine, and we returned the success callback and we processed it. But in a real world scenario, this is not like, it's not always happy cases. There's not always happy cases. Here, maybe the upload file throws an error, okay? And this is very common. So what will happen? And this is the third thing you need to know about the fork join. We said that it emits only one time. It respects the order. It emits, of course, the last value of every observable. And the third thing is that when an error happens, it will not emit at all. The stream will be completed, okay, and you will not be able to receive values anymore starting from that point. So you will see nothing emitted there because an error happens, okay? And this is not the desired like behavior in a real world scenario. Again, if we take the upload as an example and we carry on, give an example on the upload scenario, which is an example of bulk operations among others, of course. Well, in the upload, for example, the user needs to know what's the error, okay? For example, am I uploading a file that exceeded a limit? I need to know, and you need to handle this in the interface. To handle this error, you need to like display an error message saying that you exceeded the size or the normal size fixed, or the uploaded format is not allowed. Okay, you are not allowed to upload that kind of format. I don't know. There are many like errors related to the upload. Okay, so I need to know it. I need to process the errors and display it to the user. Okay, so what can we do in this case? In this case, we can use the CatchError operator, okay, which is like the secret ingredient in every recipes I'm going to show you throughout this presentation. And yeah, so the CatchError operator, well, we have to in every like observable, in every past observable, we need to pipe it and use the CatchError operator and handle the error. Okay, and here I am not handling the error, I'm just returning an observable of this error, kind of telling the stream like, yeah, you need to be alive. Okay, I will just pass to you this stream, this new observable, and carry on your work. Okay, just to enable the fork join to carry on listening to the streams, to the past streams. So here, if we do this, the fork join will emit something currently. Okay, so it will not like complete, and nothing will get emitted. So here, all that you have to do is catching the error inside the past observable itself and handle the errors. Okay, so here again, I am just returning an observable of error, but which will contain, like, the error can contain the file status every time, and then I can like test on the file status in order to differentiate between the success case and the error case. Okay, so you need, when like wrapping the errors, here I am just wrapping the errors and catching it and wrapping it in another observable. So you need to detail this wrap, okay, in order to like make a difference later on between this result and the other kind of result. So here, yeah, so here how I dealt with the error case, and now let's move to another case, which is like dealing with side effects with fork join. Okay, so let's suppose that we want to calculate the progress of the files to be uploaded. Okay, so yeah, I want to display to the user the percentage of progress. Yeah, and how can we do this? Okay, the fork join only emit one time. Okay, but I need at some point to intercept the completion of each observable in order to do some treatment. This is the idea. So in order to intercept like the completion of each observable, you can use the finalize operator that will get called when the observable completed. And at this point, I can introduce any kind of side effect I want to do. In my case, I want to calculate the progress. And for here, I am using like a custom function to track the progress. And yeah, that's all. Okay, so and this percentage, I will subscribe to this percentage and displaying it to the user in a suitable loading component or any equivalent. But yeah, but the idea is like you want to intercept the completion of each observable and do some treatment. Okay, and again, this works alongside with fork join. Okay, you can then call the fork join and pass the observables that you did like some manipulations on the stream to handle the errors and to intercept the completions. And like with all those details, we dealt with the basic requirement of the bulk operations, which is dealing with the success case, okay, just one time, and dealing and handling errors, second like requirement. The third one is introducing some side effects when the completion of each observable arrives or when each observable completes simply. Yeah, so those are like the requirements, and this is how I dealt with bulk operations in a reactive way in my Angular application. Let's move now to the second recipe, which is caching. Okay, how you can cache HTTP requests. And let's see what's the requirement in this case. So we have many components. Those are my components in the left side. And I have an Angular service, which is my recipe service. And here, my observable of recipes that holds the list of recipes of my application. Okay, so this recipes dollar is an observable, as I said, of recipes, and I collect those recipes from my back end. Okay, I am calling an HTTP, I am performing an HTTP request in order to invoke a RESTful resource, okay, to get those data as JSON. So yeah, this is like exactly the case, and I am subscribing to this observable in many components, more than one component. Okay, I am using the service, I am injecting it in my components and subscribing like to the recipes dollar every time. So what will happen in this case is that you will see like double calls in your network, double calls every time there is a new subscription. Okay. And we need to optimize this. So what we will need is the share replay operator and the CatchError operator. And here, let's see what is going on at the level of this service. Here is my service, here the recipes service. And I have the recipes dollar in which I am collecting the recipes as a stream. So as I told you, here the get my get function, and I am just processing the error, and that's it. Okay, and I want like to shed some light about this like pattern in Angular, because when you provide your observable publicly in your service, you can like benefit from the power of streams. You can combine them. You can do many manipulations in the streams. You can after that like avoid the ng on init lifecycle loop. Every time you have to call your service in the ng on init, and this will cause some performance troubles, and like some user experience issues if you like open one component and navigate from one component to another in routing, etc. So like this pattern, if you don't use a method that retrieves the recipes every time you like externalize it in one variable publicly to all the external world, to all the external components, then you can benefit like from like the power of streams. And yeah, so this is like a recommended pattern I want to shed light on. And here, in order to share all this, to share this observable with all the subscribers, you need to call the share replay operator in your stream. And the share replay operator falls under the category of multicasting operators. Okay, and here for those who like are not familiar with this word multicasting, multicast is the opposite of unit cast. And when we say unit cast, we mean that every subscriber to the unit casted observable will have its like separate execution. Okay, it's only like unit casted to that subscriber. When we call the multicast when we say multicast operator, the subscription or the data can be shared along all the subscribers, with all the subscribers. The data emitted by the observable can shared between all the subscribers, while with unitcast it's like the opposite. Okay, every subscriber maintains his like separate execution for this like for this observable. So it has its own reference of data. And yeah, and we need like multicasting operators are very useful in those like kind of situations when you want to share this observable with all the subscribers without having like to for example, with HTTP calls, call the same HTTP over and over again every time for all the subscribers. Sometimes also there are some you have some side effects in your subscription, and you have heavy computation, and you are doing some kind of treatments that's expensive, okay, for you. Then you don't want this to get repeated every time a new subscriber arrives. Okay, so you have to like cache it in a way that all the subscribers can use it. Okay, and here is the power of the share replay operator. And yeah, and in this case you can like share this image or the observable with all the subscribers, and you can optimize like your code and the execution and your runtime performance. Yeah, so now let's move to the third recipe, which is combining streams. Okay, so as we said, it's like highly advisable to externalize the streams like publicly and to make them available for the external world and for the components, etc. And yeah, for the reason that we want to do some manipulation. One of those reasons is doing manipulations on the stream. So combining streams is one of those use cases. Okay, and it's like a real world analogy is like data joining in SQL. For those familiar with for SQL, and you want like simply to join the data from different tables in order to execute one query and to deliver a result. It's the same thing, okay? You have many streams, you want to combine them in order to give the result later in any kind of like display. And here, what we need is three ingredients: combine latest, CatchError, and array destructuring technique. And let's start with the combine latest, which falls under the category also of combination operators. Okay. Earlier we saw the fork join, which is like available in the same family of operators. Combine latest has a different behavior, okay, and I will explain it right now. It takes as a parameter a list of observables, okay, in order to combine them, and every time the combine latest, every time one of the observable emit one value, the combine latest will emit in its turn this value, okay, and it will check for the other observable's last emitted value. Okay, let me explain in this marker diagram. So here at this point, the first observable emitted the A value, and the second one emitted one value. So here we have a 1. Now, at this point, the first observable emitted B. Okay, so the combined latest should emit in its turn. But before emitting, it will like check the other observables' last values. Okay, so here the last emitted value by this, the second observable is 1, so it will emit B2. At this point, there is a new value emitted from the second observable this time. So this should be emitted, okay, to the subscribers of combined latest. Okay, hello, there is a new value, there is an update, there's an update, you should be aware of this update. So the combined latest will not only return to, but it will check the other observables latest value. Okay, so here the last value of the other observable is B, so it will return B2, and so on and so forth. So every time you have the last emitted value by each of the past observables as a parameter. So a real world example is like my recipes application again. I have an observable containing the recipes dollar with containing the recipes, which is called recipes dollar, and I have another observable named reviews dollar, which is containing the reviews of the recipes. Okay, and I want like to combine every time the last recipes with the last reviews, okay, in order to get again every time the updated reviews on each recipe, okay. And this is the point, okay. The recipes and the reviews are like stored in different data structures, and I want like to do but there is a relation between them, so I want to display like this indication to the user, the review of the last reviews of each recipe. Okay, so I will use the combine latest in order to like get the last emitted values of each stream. And here you will have like the object, the array of recipes and reviews, and you can use, as you can see here, the array destructuring technique from ES6 in order like to extract the result as an object. And here I can do something after both recipes dollar and reviews have emitted something, okay, have emitted the value. Okay, I can like do my treatment and do whatever I want in order to process this. Okay, and this is like very useful in this kind of situation when you have many like when your data is like every time externalized in streams, and there is relation between your streams, and you need to get updated about the last value of each. So think about the combined latest. Maybe it's a candidate in your situation. Now let's move to the fourth recipe, which is avoid memory leaks. Okay, and here it's an important subject, how to manage the unsubscriptions. Okay, so it's very like fun dealing with streams. It's very useful. You have like clean code and a reactive patterns every time implemented, etc. But don't forget to manage the unsubscriptions of your or to your observables every time. Okay, so here, because it's a cost and it will harm your performance at runtime. So what we need in order to do this, I have some ingredients: the async pipe, take until, first, take last, and first. And I will explain those ingredients or how to use those ingredients in our recipe. So here, first thing you can do is let Angular manage the subscription for you. Again, I have like an Angular application and I am dealing with observables. So I can like let Angular manage the subscription for me using the famous async pipe operator. Okay, I think that you may all be familiar with the async pipe if you are using Angular. If not, so this pipe, like, first of all, do the subscription for you. You can use it in your template, of course. It like manage the subscription for you, and best of all, manage the unsubscription for you. Okay, so it will here unsubscribes from your observable when the component is destroyed. And again, you can use it in your template, and you have like your observable in your component. And yeah, you don't have to care about the subscription and the unsubscription because it will automatically handled by the async pipe. So this is like very cool, and it will manage the unsubscription for you. But in some cases, you can do this. You don't have the logic inside your templates, but inside your components instead. So in this case, like, you can let RxJS manage the subscription or the unsubscription for you here. And there are some operators that like manage automatically the unsubscription. For instance, take while, take last, first. Let's take the example of take, for example. So here I have the interval 100, and this will emit one value for me every 1 second. And I'm not like interested in other values. I am only interested in a specific number of values, 5 values, 6 values, whatever. Okay, so you can just use the take operator, pass the values, that the number of values that you are interested in, and this will like complete. As you can see here, I am login completed in the finalize operator, okay, to track the completion of this observable. So it will complete right after delivering or emitting the requested values for you, which are 5 values. Yeah, so this is one of the operators that you can use. There is take while also that you can use in order to take the subscription until another observable like continues to be alive, or yeah, continues to be alive. That's it. And take class is the opposite, and first it takes the first value and then unsubscribe. So those are there are some kind of operators that you can use inside your logic when you're working with RxJS observables. Yeah, so bear in mind that there are some kind of operators that manage this directly for you. So if you can use them, then go for it, because like it's It's very useful in this kind of situation. You can look further. There are many libraries like RxAngular, Until Destroy, in which like you can let this part of unsubscription and all this stuff get managed in those libraries. So you can use it by implementing state and which is the reactive component state management of the Rx Angular, or use the until destroy for the to unsubscribe directly from Angular components and all the stuff. Yeah, so there are two libraries you can check out, and you can do it yourself, okay, by like every time when you have an observable and you subscribe to this observable directly in this code, you can use the take until operator to take this subscription on until the past observable as a parameter like completed. And this you can like now you have more control on this observable path as parameter. You can decide when to complete it. In my case here, it's a subject, okay, and I am using this subject to benefit from the multicast behavior to just multicast values to this subject. And in the ng on destroy here, in my case, I am using like the regular example. It's very recurrent. It's a very recurrent pattern, and I am like sending a value to in the ng on destroy, and then completing. And complete here is optional, okay. But yeah, I just wanted to highlight how this works. So yeah, so you can do this and you can handle the unsubscription yourself. There are many ways, but just keep in mind that every time you're dealing with observable, especially in your Angular components, consider unsubscribing and managing the unsubscription to avoid memory leaks. Well, so here also there's an example of like merging streams. And then if you have like this kind of operation, which is merging streams or combining streams and all this stuff, you can subscribe on the result, okay? You can like unsubscribe to the result of merge, and this will like RxJS will handle the unsubscription for you of each past observable. Okay, so this will make your code cleaner and more readable. So keep in mind this feature also. Now let's move to the following recipe, which is sharing data and sharing data between components. And what we need here is the behavior subject, Angular servers, an observable, and the update function. So let's go and see the requirements. So here, as you can see, I have many components, C1, C2, C3, C4, and I have some kind of data that's shared between my components. Okay, so here, and this data is consumed by some components and updated by others, or maybe consumed and updated by the same components. Okay, so this data is shared. So how can we deal with this in a reactive way? How we can like share this data somewhere in order to like make every component consume and update this data without like with a little bit of optimization. Okay, so here let me just highlight something before I carry on. In this case, maybe your application is subject to state management, and you have like to introduce state and to introduce the Redux pattern. For Angular, for example, you can use the NGRX implementation. There are others implementations, but yeah, maybe your application in this case is subject to state management if you have more than one shared data and you need to like manage the state of your of all your application in one single source of truth. So yeah, in this case, your application is subject to state management. So consider introducing an implementation of Redux application. But sometimes you have a small application. It's not like subject to states, but yeah, there is like one or two kinds of data that you need to share between your components in order to optimize and to enhance the user experience, to make your components react instantly to some changes together. Yeah, so in this case, so this is the case I am talking about. And in this case, the behavior subject is your hero. So here you can the behavior subject is a special kind of subject. Subjects are observable and observers at the same time. Okay, so you can subscribe to in order to get values, and you can also broadcast or multicast values to all your subscribers at the same time. So yeah, they are multicast. And for plain subjects, regular subjects, you will only get data after your subscription. Okay, so before the subscription, you will not get the emitted data by the subject. Okay, so this is the restriction. For the behavior subject, there is a little bit of difference. The behavior subject will emit for you every time the last emitted value. Even if you subscribe late, again, you will be able to get the last value emitted before you subscribe. Okay, so this is the difference number one. The difference number two is that it accepts a default value, and yeah, so you can just put your default value according to the type you are going to handle. Okay, if you are interested in like all the previous values sent or emitted before your subscription, then the replace subject is a candidate for you. But here, let's say that we are only interested in the last version because yeah, don't forget that you want to share that data and you only need the last value of this data. I don't care for the others. Okay, so only the last updated value. This is the last image for me that I want to display or to use for any other treatment. So here what you can do is using the behavior subject in your service and extracting the observable from this behavior subject. As we said, it's an observable and observable at the same time. And in the update recipe here, I have like a method which is update recipe, and this method will always send the most recent value of the recipe title to my subject. Okay, so the idea is like having a behavior subject that will hold also or will emit the last updated value for you. You send to this subject the last updated value, the most recent version of the value, and you expose to the external world the observable. Okay, so that other components, Angular components, can subscribe to it. Okay, so here in my case, I am like just here triggering the on-click event in order to call the update service, which will send the most recent data to the behavior subject, and then like when I subscribe to this observable, I will be able to get the most recent value of my recipe. Okay, as simple as that. Like behavior subject, update the value to the behavior subject using the next method. You can like choose in when to update it. In my case here, after the on-click event, and then subscribe to the observable, and you will get automatically the last emitted value or the most recent version of this value. Well, let's move to the following recipe, which is real-time using WebSockets, how to consume real-time data. Again, here we have as ingredients the WebSocket subject and an Angular service. And here RxJS ships with an interesting kind of subject, which is the WebSocket subject that can consume real-time data coming from WebSockets. And in order to use it, you have to import the factory function available in the RxJS package, which is the WebSocket function. Pass to it your URL endpoint, the WS endpoint, and you can like use many those properties in order to introduce some customization to your to the events. Okay, you have to like you want to introduce specific behavior in specific moments of the socket lifecycle, like the opening of the opposite of the connection, the closure, etc. So you have like a special kind of object in which you can perform some optimization or customization to be more accurate. And yeah, so this is in a nutshell. If you are interested in this topic, I have like in my GitHub repository two projects, NG real time and NG real time dashboard. One version with NGRX, one version without. You can check it out. I talked about this subject in many talks, and I have like many resources and articles in the net about the subject. So if you are interested in it, you can like check this out. And the last like recipe is yeah, to stay healthy, stay up to date, and upgrade to RxJS 7. And there are a lot of amazing features introduced in the last version of RxJS. Banlish will tell you about in the RxJS what's new in RxJS 7. And yeah, so just try to check out the version and start like playing around it. Yeah, and that's it. So thank you very much for having me. That's all I have to tell you today. Stay safe, and if you have any question or any feedback, don't hesitate to like ping me on Twitter. My DM is always open, and I answer also on LinkedIn, my mail, and I have like some articles on Medium, and you can check out my GitHub repository for to get inspired about some projects. That's it. Thank you very much, and stay safe.